Hello my dear students, in this lecture we are going to see vapor pressure curve. That is, in this lecture we are going to see the phase change of vapor state into liquid state or liquid state into vapor state and corresponding liquid vapor dome. Now my dear students, every liquid boils at particular temperature corresponding to particular pressure, and the temperature at which liquid boils is called saturation temperature. The temperature at which liquid boils is called saturation temperature, and the corresponding pressure at which this liquid starts boiling is called saturation pressure. And my dear students, as this saturation temperature and saturation pressure are related with each other, that means as saturation pressure on the any liquid increases, its saturation temperature also increases, and vice versa. That means if saturation pressure on any liquid decreases, then its saturation temperature also decreases. And saturation condition is nothing but boiling condition. Therefore, here we can understand like this: saturation condition is nothing but a phase change. At this condition, there will be always a phase change. Right? At saturation condition, there will be a phase change, and boiling is a phase change. In boiling, the liquid is converted into vapor. Right? Whenever liquid starts boiling, it will boil at particular pressure corresponding to particular temperature. Let us take an example. Water boils at water boils at 100 degrees Celsius if pressure on the water is equal to 1 atmosphere. Means in this case, the saturation temperature is 100 degrees Celsius, and saturation pressure is 1 atmosphere, that is atmospheric pressure. So my dear students, if this atmospheric pressure changes, then saturation temperature also changes. That means we can say, if pressure on the substance increases, then its boiling temperature also increases, and vice versa. That means if pressure on the substance decreases, then its boiling temperature also decreases, right? Similarly, therefore, if I draw pressure versus temperature diagram, right, then as the pressure goes on increasing, boiling temperature also goes on increasing. Now here this side is solid state, and here there will be a liquid state. Sorry, here here on one side there will be a liquid state, and here there will be a vapor state, right? Or liquid plus vapor dome, we can say. Means as saturation temperature increases, let us see here, as saturation temperature, let us say this is the saturation temperature particular. Corresponding to this saturation temperature, there is a saturation pressure. Now as pressure decreases, saturation temperature also decreases, and as saturation pressure increases, saturation temperature also increases. Now let us understand these things by considering few examples. Now we have taken one example, that water boils at 100 degrees Celsius if pressure on the water is atmospheric condition, right? Now let us understand this diagrammatically. Here here corresponding to every pressure there is always saturation temperature, right? Let us say one vessel is open to atmosphere, and in this vessel there is a water, right? And now this water is heated. Here this water is heated, means heat is supplied to this water, right? Now this water will start boiling, that is phase change will start at 100 degrees Celsius, because this vessel is open to atmosphere. That means on this vessel, the pressure is atmospheric pressure, right? Therefore in this case, saturation temperature is 100 degrees Celsius and saturation pressure is 1 atmospheric pressure. Now let us take, without this vessel, if I use pressure cooker, let us say there is a pressure cooker. Now this is a pressure cooker on which weight is kept. This weight is kept on this pressure cooker, right? Now my dear students, and in this pressure vessel there is a liquid, that is, let us say there is a water in this pressure cooker. Now heat this pressure cooker. If I heat this pressure cooker, then now what is outside is weight this placed on the pressure cooker as well as atmospheric pressure. Means outside pressure is now more, right? Now what is the pressure on this pressure cooker? What is the pressure? Atmospheric pressure plus weight divided by area. This is the pressure acting on the pressure cooker, right? Therefore pressure is increased. Therefore as pressure is increased on this water, this pressure on this water surface, we can say, is more than atmospheric pressure. Therefore, the boiling temperature of this water will be more than 100 degrees Celsius. These concept we are using for the cooking, right? Because many times, let us say, the mutton or chicken will not cook at 100 degrees Celsius. Therefore, we need more temperature for cooking of mutton and chicken. So we are increasing pressure on the pressure cooker so that the pressure on the water surface will increase, and hence the boiling temperature will increase and there will be a cooking, right? Similarly, you might have heard that, let us say this is the earth surface. Let us say this is our earth, and here this is the surface of earth. Now as we go away from the earth surface, then pressure goes on decreasing. As we go away from the surface, the pressure goes on decreasing. Now let us say, if I consider example of Himalaya, let us say there is a Himalaya, this is a Himalaya Parvat, right? Or Everest, this is a Himalaya, right? Now, and here it is a sea level. Let us say this is a sea level. Now, as we go away from the sea level, the pressure goes on decreasing. Pressure goes on decreasing. That means at the top of Himalaya, the pressure is less than atmospheric pressure. At the top of this Himalaya, pressure is less than atmospheric pressure. Therefore, at the top of Himalaya, the boiling temperature, that is called saturation temperature, boiling temperature will be less than 100 degrees Celsius, right? Because at atmospheric pressure, the boiling temperature is 100 degrees Celsius. Therefore, at the top of Himalaya, the boiling temperature will be less than 100 degrees Celsius. So, many times at 20 degrees Celsius, 30 degrees Celsius only, the water boils at the peak of Himalayas, right? Because of this, and at this very low temperature, we cannot cook. So we need compulsory pressure cooker at very high ranges, right? That is in Himalaya. Now, my dear students, when your liquid is converting into vapor, there is a concept of dryness fraction. There is a concept of dryness fraction. Now, this dryness fraction is also called quality. It is also called quality, and it is represented by X. It is represented by X. Now, my dear students, whenever liquid is converting into vapor, now total mass is, here we have total mass. Total mass is nothing but mass of liquid plus mass of vapor, right? This is the total mass. And my dear students, whenever liquid is converting vapor, that means mass of vapor is increasing, hence mass of liquid is decreasing, but the total mass remains constant. Now, dryness fraction is nothing but, this dryness fraction is nothing but, it is a ratio of mass of vapor to the mass of liquid plus mass of vapor. This is called dryness fraction. Therefore, it is a ratio of mass of vapor to the mass of liquid plus mass of vapor. Therefore, it is also called mass of vapor divided by total mass, divided by total mass. This is called dryness fraction. Now, let us understand this concept of dryness fraction. My dear students, this dryness fraction is equal to mass of vapor divided by mass of vapor plus mass of liquid, right? Now, whenever mass of, first condition, whenever mass of vapor becomes equal to 0, then numerator becomes equal to 0. That means total mass is mass of liquid. Therefore, the dryness fraction becomes equal to 0, and it is called saturated liquid state. This state is called saturated liquid state. Liquid state. And at saturated liquid state, dryness fraction is 0. That means there is only liquid state and mass of vapor is 0. Means it is a start of phase change. We can say start of boiling. Start of boiling where vapor is 0. Now second, whenever mass of liquid becomes 0, mass of liquid becomes 0 means total mass is equal to mass of vapor, right? Therefore, dryness fraction becomes equal to 1. It is called dry saturated vapor state. It is called dry saturated dry saturated vapor state. Vapor state. That means, my dear students, all the liquid is converted into vapor. Therefore, it is the end of boiling. End of boiling means phase change is occurred. It is the end of phase change. Therefore, start of phase change whenever there is a boiling. That means for liquid to vapor phase change, for liquid to vapor, that is means for vaporization, the start of phase change is from, the phase change starts at x is equal to 0, saturated liquid state, and ends at x is equal to 1, that is dry saturated vapor state. But my dear students, for phase change from vapor to liquid state, it is called condensation. It is called condensation. That means from vapor to liquid state, the start of phase change is at x is equal to 1, that is dry saturated vapor state, to the end of phase change is at x is equal to 0, that is saturated liquid state, means total vapor is condensed here. And generally this dryness fraction or quality varies from 0 to 1, and whenever this dryness fraction varies from 0 to 1, then the substance will be having liquid plus vapor dome. It is in liquid plus vapor dome, therefore it is called wet region. This region is called wet region. So my dear students, in next lecture we are going to do analysis of this wet region. Thank you dear students. In next lecture we will see representation of constant pressure lines on temperature versus entropy diagram.